Now, okay?
Yes, sir.
Okay. So here the heading is safety features in modern anesthesia workstations. Okay. So they can be subdivided into the following categories. One is gas supplies from the central pipeline to the machine as well as from cylinders. Then the second thing is about flow meters. Third is about vaporizers. Regulators provide a constant low pressure to the machine. This is a very important point. So whatever high pressure that is coming from the pipeline or the gas cylinders, unless they are reduced to 14 psi, it will cause barotrauma. So pressure regulators play a very important safety mechanism in reducing the pressure and at the same time providing that same constant pressure. Now, up to this is the high pressure system. Up to the pressure regulator is the high pressure system. From there onwards, the pressure is reduced and it goes to the intermediate pressure system. Of course, in the high pressure, Schrader probe is given to prevent pipeline being fitted. Schrader is introduced here because the pipeline pressure that is coming is only about 50 to 60 psi. Whereas the gas cylinders which are attached to the machine and open, they are going at 1500 to 2000 for oxygen and 750 for nitrous oxide. So that comes under high pressure. Whereas the pipelines, even though books all show that under the high pressure system, actually they at that level it's only an intermediate pressure system. And the hose pipes are king proof, color coded and flexible. And gas pipelines at the machine end are connected with a unidirectional valve so that there is no reverse flow and they are color coded and matched with a specific gas service. And there are pipeline pressure indicators as well as the cylinder pressure indicators in the modern anesthesia workstation. Whereas the earlier anesthesia machine, they will show only the pressure gauge will show the gas cylinder pressure. There is no indicator for the central pipeline pressure service if it is connected to the older anesthesia machine. Whereas all of you will be aware because most of you are now using only the workstations in majority of the hospitals. The panel displays both the cylinder pressure as well as the central pipeline pressure, which is again a safety measure which has been incorporated in the workstations. And comes the oxygen failure system, that's a loud alarm and to indicate that there is a fall in oxygen level, whereas older machines had what is called the Ritchie whistle to alert the patient when the pressure drops. And the oxygen flush which is used is located in a shallow recess and it is activated by finger and it will return back to its normal. If you see in the earlier machine, it will have a rotating type of button which can be pushed and then kept on for a long time without your finger being pressed. Whereas in the modern workstation, every time you want to activate it, you have to press it with your finger, and then once you remove the finger, it will automatically revert back. So that is a very important safety feature, because in the older machines, it can be kept activated without your finger being on the control switch or the button. So that may result in barotrauma. So that has been avoided in the modern day workstations. And next comes the low pressure system, which is starting from the flow meters, and each one has got a knob to identify. For oxygen, you have a little larger knob with larger flutes. It is color coded, and the name of the gas is also written there. And uh, so and the older machines used to have a fluorescent backdrop, because if there is no power in the theater, suddenly the whole theater becomes dark, which has used to happen in the earlier days when we were students, because there were no backup battery service or the generators were not there. So they had a fluorescent backdrop of all the flow meters, so you can see the flow meter flow even in darkness. Whereas in the modern workstation, some of the flow meters have a separate light which will switch on. If there is a power failure, they will switch on so that you can see the flow of the gases in the flow meter tubes also. So that is again a safety feature which is there to indicate that gases are flowing. And of course, the placement of the flow meter. Earlier, it was oxygen in the first place, followed by nitrous oxide, air, and other gases. Nowadays, the oxygen has come to the downstream position, third position. So you have nitrous oxide, air, and then oxygen, which is supposed to prevent a hypoxic mixture. And how these flow meters are activated and how the hypoxia is prevented. So hypoxia prevention, which you mentioned, minimum mandatory oxygen flow, and then so it is most of the machines have a minimum mandatory oxygen flow of 50 to 250 ml per minute, depending upon the manufacturer. And there is a minimum oxygen ratio to give at least 21% to prevent hypoxia. Then there is a mechanical linkage, which all of course he mentioned. And these devices not only linked to oxygen and nitrous oxide. So it is not linked to the air. So nowadays we are commonly using medical air. So air is not linked to the safety devices because air itself contains oxygen. So that is the reason why they have not linked the oxygen and the air, but it is linked only to oxygen and nitrous oxide. And there is an electronic linkage which proportionate the oxygen concentration to a preset minimum depending upon the feedback. And there are alarms which give you an audible caution that oxygen level is going down. Now vaporizers have a stiff button that has to be pushed to turn so that they can be activated. So this is again something like a lock, which is again a safety feature. And prevent all vaporizers working simultaneously, there is an interlocking system at the back bar. And pressure relief devices are located between the common gas outlet and the vaporizer. Most of the machines have that. And it protects anesthesia machine by venting gases to atmosphere if there is a high pressure developing within this region. And the tilting of the vaporizer, which will prevent the spillage of liquid into that bypass chamber, is again another newer safety machine in the newer vaporizers, and it is marked by the alphabet T. So if you keep the dial at the T position, even if it is turned to 180 degrees, the liquid agent will not come into the bypass chamber. So that is a question they ask you in the Viva also. What is the indicator? Why it is? What is the importance of that word T? It is for the tilting position and how much angle you can tilt without causing any spillover is 180 degrees is the answer. And they have the teeth and funnel filling system, and they are all agent specific. Okay, these are also part of the safety features which you have to mention. And the bottle end of the connector has got slots that match to the projections against the bottle. Then coming to the common gas outlet, newer machines have more than one common gas outlet. So the machine standards ensure that only one common gas outlet is functioning at any given time. Now coming to the scavenging system, all scavenging system connection have 30 mm diameter so that you don't by mistake connect it to the breathing circuit. So these are larger diameter connectors, and they have negative and positive pressure relief valves which are incorporated into the scavenging system to prevent transmission of high pressure into the breathing system. And every anesthesia machine is installed with a standard oxygen analyzer, a low pressure analyzer. These are all present in the modern workstations. These are all not present in the older machine. That's why I told you, if the question is worded anesthesia workstation, you have to include all these answers. And a low pressure analyzer, a high pressure analyzer, and even a spirometer. And coming to the monitoring system, which come along with the modern anesthesia machines, these have become the mandatory monitors. One is ECG with a 5-lead configuration, blood pressure test for an automatic NABP measurement, pulse oxygen saturation monitor, end-tidal CO2 monitor, tidal volume and airway pressure monitor, temperature monitor. Sometimes peripheral nerve stimulator also is included, especially for patients undergoing neuro procedures or other super specialty theaters. And end-tidal vapor monitor to know the whether the concentration delivered is being correctly, accurately given to the patient. And there are even the other latest monitors which are included in newer machines are ultrasound to detect pneumothorax or abdominal problems. And what are the extra monitors required for high-risk patients? They include invasive blood pressure monitors. So you have the IBP monitors, CVP monitors, and pulmonary artery pressure monitors, and intracranial pressure monitor, and sometimes transesophageal echocardiography, sensory and motor potentials, EEG, fetal heart monitor in high-risk pregnancy patients, and uterine contraction monitor. All these things are incorporated. And the BIS monitor and cerebral oximetry. All these things are included as part of the anesthesia workstation in patients who are at high risk. Okay. So these are the points you have to include in your answer to complete your answer. Okay. So please add the other